Reusable calculus will proceed discussion. Reusable calculus, the arena in which we are making the discussion. Can we use calculus as a hardware component or a software component? Typically, we use whenever we write anything, we intend to use it in future. Whenever we write anything, okay, if I'm writing a piece of program, then it should be reusable. That is the concept. Tomorrow I should be able to use it. If I'm developing an electronics component for a particular circuit, then that electronic component should be used in other circuits also. Somehow, like this is a electronic circuit, and these are the components in the electronic circuit. The concept is I should be able to use these 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 kind of devices into other circuit also. If this is a device called capacitor, and I'm able to use this capacitor, consider this is doing some work X, and I have another circuit which is doing a work Y, and there I am able to use same capacitor there also. I can say this is reusable. I can reuse it at other places also. Typically, reusability goes upward. Upward means lower kind of upward means kind of lower complexity to higher complexity, lower domain to higher domain. Means if I have a capacitor, it will be used in a circuit. Consider this is a circuit. This is a circuit in which this capacitor is used. If this capacitor is used in this circuit, can this full circuit can be reused at some place? Yes. In larger circuit, there is a potential chance that this will be reused in larger circuit. If this capacitor, if this capacitor is used in this circuit, then this capacitor should be used in other circuit also. That is one thing. Now I have this full place circuit, print board circuit, PCB, on which full place circuit is there. Can I use this full place circuit into a bigger circuit if I'm able to use at n number of places, at so many places? Then this is called reusable. This is reusable. Now, if I see this, then inside this I have a capacitor. If I take out this capacitor and place in other circuit, then capacitor is reusable. Everything is reusable in bigger domain. If there is a capacitor, then it will be used in a circuit. If there is a circuit, then circuit will be used in bigger circuit, and so on. If I have something in calculus that is integral calculus in single variable case, then that should be used in multiple variable case also. I mean, what I'm saying is, consider I have calculated a single variable integral calculus. Consider I have calculated a single variable integral calculus. That integral calculus can be used in multivariable case. There that is higher domain. Single variable to multivariable domain is the considered as a higher domain. Okay, if it is considered a higher domain, then lower domain, that is single variable integral calculus, can it be used in a higher domain? That is the question mark. Yes, it should be able to use it. We will do more example. Actually, I'm excited about the grandi series. Grandi series is really amazing. What is grandi series in single variable case? Grandi series in single variable case is 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1 up to infinity. What is the addition? Someone would say if it is going to infinity and the last point is 1 again, then summation will be 1. If last point is minus 1, then summation will be 0. But Sir Grandi is saying that no, summation will be 1 by 2. 1 by 2, not 1 nor 0. 1 by 2. This is very, very fascinating Grandi series. 1 minus 1, 1 minus 1, 1 minus 1 up to infinity. The solution is 1 by 2. And we are the first one who has proved it, that through integral calculus also grandi series calculation is possible. Okay, this is called single variable integral series. Now can I, so what is this? This is sigma summation x equal to 1 to infinity. Sigma, sigma summation means sigma x equal to 1 to infinity function over x. What is your function over x? Means fx up to infinity. What is function over x? Consider x is 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. At x equal to 1, fx is 1. At x equal to 2, fx is minus 1. X equal to 2, fx is 1. Fx, x equal to 4, fx is minus 1. 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1. And this is how it is. The question is arising, how we can sum it? That is the one. Okay, what is the algebraic formula of this series? This is minus 1 to the power x minus 1, where x is the position number in the series. If position number is 1, then answer is 1. If position number 2, then 2 minus 1, that is 1, minus 1 to the power 1 is minus 1. If it is 3, then 3 minus 1, 2, minus 1 to the power 2 is 1. So 1 minus 1, 1 minus 1, 1 minus 1 up to infinity. So the algebraic equation is minus 1 to the power x minus 1. This is the formula. And if I say summation x equal to 1 to infinity minus 1 to the power x minus 1, answer is 1 by 2. How to find it, we will talk. What I want now. Okay, what I want now. I want summation x equal to 1 to infinity. Okay, I want summation x equal to 1 to infinity. Understand it? X equal to 1 to infinity. Summation y equal to 1 to infinity. Makes sense? Summation z equal to 1 to O. Makes sense? Summation x equal to 1 to infinity. Summation y equal to 1 to infinity. Summation z equal to 1 to O or 1 to infinity. Z also 1 to infinity. fxyz. Function over x, y and z. fxyz. Okay. What is fxyz? fxyz is y plus z whole by x. Y plus z. Hope. I'm sorry. I'll rephrase this. X equal to 1 to infinity, y equal to 1 to infinity, z equal to 1 to infinity. fxyz, where fxyz is minus 1 to the power y minus 1 plus minus 1 to the power z minus 1 divided by minus 1 to the power x minus 1. There are three grandi series here. Summation of y and z divided by x. This is the question now. How we can solve it? Okay, let's solve the single variable. Many times we have solved it, we will do it again. Single variable. We want summation of fx, where fx is minus 1 to the power x minus 1. To solve it, we will use successive approximation and we will convert this function into a continuous function. This is a discrete function. Minus 1 to the power x minus 1 is a discrete function. Means this algebraic equation will work only when x is 1, 2, 3, 4, 5, 6, not in fraction value. So this should be considered as a discrete value, discrete function. Minus 1 to the power x minus 1, where x is always a whole number. Okay, can we convert this to a continuous function? That is the question mark. Can I convert this to a continuous function? Okay, to convert this into a continuous function, we will use successive approximation. Means fx equal to gx dx. I have to find a continuous function gx such that dx dx, if I integrate gx dx, from x equal to x to x plus 1, that will give the same as fx. I mean minus 1 to the power x minus 1 should be equal to limit x to x plus 1 gx dx. Limit x to x plus 1 dx dx. What I'm trying to say, if this is x-axis and at any point x I have fx as a discrete function, x to x plus 1, this is the area strip, it will go and hit a continuous function called gx. It will form an area, and that area will be same as at left hand side fx. This means that whatever fx we have, fx at x equal to 1, 2, 3, 4, all fx will be equivalent to right hand side area with gx. If I have so many fx, I will have so many area with gx. Adding all the area with gx will give addition of all the fx. Means gx dx x equal to 1 to infinity, or x equal to, if I take this last point of x as n, then n to n plus 1. Everywhere x to x plus 1, the last point is n, that area will be n to n plus 1. If I am specific about n, then summation x equal to 1 to n plus 1 gx dx will give the addition of all the area, where each area correspond to 1 fx. Means summation x equal to 1 to n fx is same as limit x equal to 1 to n plus 1 gx dx. I have to find gx. Okay. Now the question is arising that fx itself is different for x equal to even or odd. 1 minus 1, 1 minus 1, 1 minus 1, and so on. If it is 1, if I see the odd positions in the series, then it is always 1. If I see even position in the series, then it is always minus 1. So we will add even, and then we will add all the, we will add all the odd position, and we will add all the even position, and then we will sum it. So then we will find gx for the even and odd slots separately. For the odd slot, let's take n is odd number. The last n up to which we are calculating, n is odd number. Then it is 1, 1, 1, 1, 1 up to n. Then it is minus 1, minus 1, minus 1 up to n minus 1, because odd position will be 1 less than that. Anyway, now if I am trying to find the fx equal to gx dx, then for odd, if it is x, then next will be x plus 2. So x to x plus 2 gx dx should be exactly same as fx, and that is 1. That is 1. Fix 1. Okay, in that manner we can estimate gx. If gx is 1 by 2, then it will be 1. 1 by 2 dx x to x plus 2, it will be 1 only. If I take continuous function 1 by 2, continuous function 1 by 2, then we have this 1 by 2, then it is equivalent to fx 1. If I take minus 1 by 2 and then integrate from x to x plus 2, then it will come as minus 1. So we have found gx for the odd and even, and then finally we will add x equal to 1 to n plus 2, 1 by 2 dx, plus x equal to 2 to n plus 1 minus 1 by 2 dx. This will give the full summation. Okay, now we are talking about the infinite series. If it is infinite, then n plus 2 or n plus 1 both are n only, and that is infinity. In that case, first integration will go from 1 to n, where n is infinity, 1 by 2. 1 by 2 dx will be x. 1 to n will be n minus 1. It will be 1 by 2 n minus 1. N minus 1 by 2. For even it will become n, it will become 2 to n. Then it will become n minus 2 by 2. Makes sense? So we have n minus 1 by 2 minus n minus 2 by 2. Okay, it will become minus 1 by 2 plus 2 by 2. Minus 1 by 2 plus 1. 1 by 2 is the answer. So through the integration also we can calculate the grandi series, and answer is 1 by 2. Okay, now we will talk about the we will talk, okay, what we have done. So final summation, what we did. Final summation is sigma x equal to 1 to n fx is equal to limit x equal to 1, x equal to 1 to n plus 2 gx dx plus x equal to 2 to n plus 1 gx dx. Both gx dx are different. I can say g1x dx, g2x dx. If I combine both as a kind of pseudocode, then it will be x equal to 1 to n plus 1 gx dx, where gx is same for even and odd. We have taken pseudocode. Anyway, and that answer is 1 by 2. Let's proceed the three-dimensional stuff that we have started. Now in 3D, we want to add summation x equal to 1 to m, y equal to 1 to n, z equal to 1 to o, where m and o are infinity, fxyz, function over xyz. Function over xyz is minus 1 to the power y minus 1 plus minus 1 to the power z minus 1 whole divided by minus 1 to the power minus 1 to the power x minus 1 whole divided by in that manner. Okay, if that is the case, then what the summation will be? Okay, if I have something called fxyz, then first I have to get the continuous function called gxyz. Fxyz is equal to limit x equal to x plus 1, limit y equal to y plus 1, limit z equal to z plus 1, gxyz dx dy dz. This is the way to find gxyz. That will be very difficult to calculate. Once I find the gxyz, once I find the gxyz, then summation x equal to 1 to m, summation y equal to 1 to n, summation z equal to 1 to o, fxyz where m and o are infinity, that will be equal to limit x equal to 1 to m plus 1, y equal to 1 to n plus 1, z equal to 1 to o plus 1. Okay, fxyz dx dy dz. Let's settle down with dz first. Then someone will say, what is your gxyz? First that you have to reveal. What is your gxyz? That is a continuous function. Okay, I can rewrite gxyz as c, continuous version of fxyz. C and in bracket fxyz. Okay, continuous version of minus 1 to the power y minus 1 plus minus 1 to the power z minus 1 divided by minus 1 to the power minus 1 to the power x minus 1, x plus z by y plus z by x loosely. Okay, if I do so, then I can break it. Continuous y to the minus 1 to the power y minus 1 by minus 1 to the power x minus 1 plus minus 1 to the power z minus 1 by minus 1 to the power x minus 1. Continuous version of these two. Gxyz, that is continuous version of fxyz. I can write as fxyz is equal to c in bracket. Gxyz is equal to gxyz is equal to c in bracket fxyz, continuous version of fxyz. Or I can write fxyz is c inverse gxyz, means discrete function of the gxyz. Anyway, now the c of fxyz is broken into c of minus 1 to the power y minus 1 plus minus 1 to the power z minus 1 whole divided by minus 1 to the power x minus 1. We can break it, and now we can break. Not required. Not required. Breaking not required. The numerator is constant. I'm sorry again. Let's try to integrate this with z first. Let's try to integrate this with z first, then y second, and x last. Then I will divide it in. Now, if I break it, it will become minus 1 to the power y minus 1 by minus 1 to the power x minus 1. Continuous version of this plus continuous version of minus 1 to the power z minus 1 by minus 1 to the power x minus 1. Now, if I integrate separately minus 1 to the power y minus 1 by minus 1 to the power x minus 1, if I integrate with dz, this will behave as a constant. So, if I try to integrate only dz, z is 1 to o, z is 1 to o plus 1. Okay, if I try to do like so, then it will become O. 1 2 3 4, that then it will be 1 plus 1 plus 1 plus 1 O times. Answer is O. So answer will come as O. Okay. O, and then minus 1 to the power y minus 1 by minus 1 to the power x minus 1. Next is continuous version of minus 1 to the power z minus 1 by minus 1 to the power x minus 1. 1 by x minus 1 to the power x minus 1 I can keep out, and then we will integrate limit z equal to 1 to O plus 1, continuous version of minus 1 to the power z minus 1. This is a purely grandi series. Now someone will say it depends upon what is O. O is negative, O is odd or even. Consider O is infinity, then it is 1 by 2. Straightforward. 1 by 2. So answer is coming as 1 by 2 y minus 1 to the power x minus 1. And this side we have O, which is infinity, but we will keep it O. O into minus 1 to the power y minus 1 by minus 1 to the power x minus 1. Now we will integrate these two separately. Now if I integrate the first one, then x with dy, then x is constant. O by minus 1 to the power x minus 1 is constant. Minus 1 to the power y minus 1. If I integrate that, that will become 1 by 2. So answer will become O into 1 by 2 by whatsoever it is. Okay, I believe this is how it is. Okay, thank you very much. Now the right hand side we have now 1 by 2 into 1 by minus 1 to the power x minus 1. If I integrate with dy, then it will become n. N terms are there. So 1 by 2 into n by minus 1 to the power x minus 1. And this side we have O into 1 by 2 by minus 1 to the power x minus 1. Both sides we have now common. Now minus 1 to the power x minus 1 dx, if I integrate, I can take the numerator as constant O into 1 by 2 outside, and then integration x to m plus 1, x equal to 1 to m plus 1, 1 by minus 1 to the power x minus 1. That will be nothing but 1 by 1 plus 1 by minus 1 plus 1 by 1 plus 1 by minus 1. That is same as 1 minus 1, 1 minus 1, 1. So result will come as 1 by 2, 1. Now 1 by 2 and numerator is 1 by 2. Okay, they will cut each other and answer will be O. O. Okay, answer will be I think so. O. Number of terms in Z. O. Okay, plus this side if I try, then what we have now? This side we have 1 by 2 into n. 1 by 2 into n divided by again 1 by 2. Minus 1 to the power x minus 1 will be 1 by 2. 1 by 2, 1 by 2 will go away, and answer will come as O plus n. The answer will come as O plus n. Okay, since we have taken it as infinity, the answer will be infinity. So if I have grandi series in y, grandi series in z, if I add and then divide by grandi series in x, okay, someone would say it looks like 1 by 2 plus 1 by 2 by 1 by 2. That answer is infinity, not 1 by 2. This is what the miraculous thing that I am seeing in the multivariable case. Okay, what we are doing, we are not expanding gxyz, we are not solving gxyz, rather than we are using gx only, 1 to n plus 1 gx dx, where n is infinity, it is 1 by 2. Same concept we are reusing everywhere. Okay, x plus y plus z by x in grandi series, if I take in 3 dimension, the answer is infinity. It's not 1 by 2. Infinity series of y is 1 by 2. Infinity series of z is 1 by 2. By infinity series of x is 1 by 2. Then it will come as 1 by 1 by 2, 2. But that is not the answer. Answer is infinity. Someone can try y into z by x. Y is into z by x. Y into z by x. If I had tried y plus z by x in grandi series, then first position in the series is 1 comma 1 comma 1. That is 1 into 1 into 1. Next one is 1 comma 1 comma 2, where x is 2, y is 1, z is 1. Then that will come as 1 comma 1 comma 1 into 1 plus, oh, I'm sorry, first one will become 1 plus 1 by 1. That will be 2. Next will be 1 plus 1 by minus 1, minus 2. Then it will be 1 plus 1 by 1, that will be 2. 2 minus 2, 2, 2 minus 2, that is how it is. And it will be in 3 dimensions. Then next row column, someone will, it will break someone's head. But anyway, thanks to the reusable calculus, which is very complex, someone can try. It's very complex. Anyway, we will try for the multiplication also in the grandi series through this way, or someone can take uprightly only. We have y plus z by x. Okay, we will try with x first, keeping yz constant. This continuous version of minus 1 to the power y plus minus 1 to the power 1 to the power y minus 1 minus 1 to the power z minus 1, and then into 1 by minus 1 to the power x minus 1. If I do so, then it will come as 1 by 2. Limit 1 to m plus 1, 1 by minus 1 to the power x minus 1 dx. This is pure grandi series in inverted manner, but I can invert it back. And this is pure grandi series, and we know grandi series calculation through integral calculus. X equal to 1 to n plus 1 n plus 1 gx dx. Here it is c, or here also it is gx dx. Okay, c of fx, continuous version of x, same thing. We can just replace it by 1 by 2, just 1 by 2, and we can keep it outside. Now then we will fix grandi series of y and z. This is what I think so. grandi series of grandi series of y. First we took out this and we fixed for x. Okay, okay, I think so. This is what we did. Okay, now we have to do it with y and z. Okay, now we have 2 into c of y and plus 2 into c of z. If I try with z first, then 2 into c of y into o, because this is full is constant, then it will be integration of dz only, means o term. And this side it will become 2 into 1 by 2. That will be, if I integrate next with z, okay, all together z, then it will be 2 into 1 by 2, that is 1. And this side we have 1 by, sorry, 2 into o. Now we will integrate all the stuff with dy and then dy. Then first term, first 2, it is coming as 2 into 2 into o into integration of the y, that will come as 1 by 2, 1 by 2, 1 by 2, gone o. And this side n. Again result will come as o plus n only, and that is infinity. Answer is infinity only. Anyone can try. We will try z into y by x, means minus 1 to the power y minus 1 into minus 1 to the power z minus 1 divided by minus 1 to the power x minus 1. Grandi series in y and z coordinate, multiplication in numerator, and grandi series in x coordinate in denominator. Amazing, mind blowing. I believe it will be very difficult. If I take the first index in this 3D, that is 1 comma 1 comma 1, then it will be 1 into 1 by 1. Next will be 1 into 1 by minus 1, 1 into 1 by minus 2. If I take next row where z is again 1 only, then it will be 1, y is minus 1, minus 1 into 1 by 1, minus 1 into 1 by minus 1. Then if I, this is a z as 1, next is z as minus 1, it will be very complex. Can someone really calculate to the infinite series? Head hitting in the wall. Anyway, these are not available in any of the books. Successive approximation and reusable calculus. Please don't mind supporting us. +91 India country code 9483160610 is the telephone number. +91 India country code 9483160610 is the telephone number. Okay, now the daily basis threatening us going on country by country. We have sorted out 15 countries. Please watch our video. 15 countries who are vulnerable to attack from the America. In that 15 country, India also come. I'm not talking about military attack only. The trade attack, economic attack, so many